Hello team. In this video, I'm looking at the RNA transcription challenge from exorcism.org. This one's cool for two reasons in my mind. On the one hand, we're working with something that is actually relevant. So right now, a lot of stuff happening with DNA to RNA, a lot of targeted therapies, a lot of cool stuff happening in that field. So being able to do something that's currently relevant is really nice. The other thing that I really like is that this can become a generalized solution. And by the time we're done, you'll see what I mean by that, where we start out with something that is very focused on DNA to RNA. And by the end of it, we'll be able to do stuff like going the other way from RNA to DNA, or doing Caesar ciphers, something like the ROT13 challenge. So lots of interesting stuff happening here, and we are going to get into it. Now, the challenge itself is to take these four characters, to take a DNA strand with the nucleotides inside of DNA and translate them to an RNA strand with the RNA nucleotides. So just a straight one-to-one translation, which means that we can start out very focused and then refine it from there. And that's exactly what we're going to do over here. Okay. I already have all my tests in place. I have a placeholder right here, which we are going to get into. Now you're going to see some errors here, and that's because I haven't done anything with this. So again, starting with something that is very targeted, okay? And what that looks like is we get rid of everything inside of this function, and we start by returning strand.map, okay? So we're going to map over the strand. The strand comes as an argument, so we're going to get that right here. That strand is a string, okay? No matter how you look at it, it's a string, which means that right here, we should actually turn that into an array, okay? And then from here, each of those letters, you can call it nucleotide if you want. That feels like a very long name for this, so I'm just going to stick with letter. And right here, we start to do stuff. Now, again, staying with that very targeted focus just to start, I'm going to use a switch statement, okay? So letter, we're going to do it. Here is our case. The first one is G, okay? So G, we turn it into C, right? That's what we were doing, okay? So just like this, I'm going to copy and paste this a couple more times because I can. And it's faster that way, okay? So G to C, C to G, T to A. I'm sure there's a joke in there. I won't go any further than that. A to U, okay? So there are letters. Because we're using a switch statement, we probably should add a default in here, okay? Which throws new error, okay? In the spirit of writing really good error messages, oops, right? Doesn't have to be anything fancy on this because we're about to get rid of this switch statement pretty quick. But switch, okay? We've mapped over this. Map will return an array, okay? So right here, after it all, we should join it up, okay? No spaces, no nothing. We're just going to sandwich all those or smush all those letters together. And if we've done this right, we should be able to run this and get a passing test, which is exactly that. It's indenting funny because of the error messages. One more time, just to make sure that I haven't missed anything. And of course it works, okay? The problem with this is that it requires a lot of developer intervention. If they all of a sudden discover a fifth nucleotide and want to be able to translate that, I have to go in here and copy and paste this to a new line and do the stuff, okay? It's very hands-on, very manual process. So maybe this information comes from somewhere else, somewhere that the scientists can edit it, and they just put it in, and we get it and use it, okay? So let's go and explore that really fast. Right down here, I'm going to take these, copy them out, and bring them up. Okay, I'm going to call it codes and make it an object. Now, again, If this was coming from an API or a CMS or something like that, then we'd probably get that object in JSON form. We can translate it. But for now, I'm just going to set it as an object, assuming that it's coming from somewhere. This is not going to work because obviously it's not an object, right? So let's go in here and clean it up. I'm going to get rid of the quotes here and then get rid of the return, go to the end, add a comma, and now we have that object, okay? And we can use it, which means that down here, all this switch stuff goes away. Instead, we just return codes letter, okay? So it's going to go in, it's going to find the letter, it's going to find the value of that, and it's going to return it, which means that now we can do exactly that. Number 5 is a pass, right? We have a couple things here. So we have map and join, okay? If we go and take this, we should be able to get rid of the join. And the way that we do that is by switching this to my old friend reduce, okay? Reduce takes a bunch of arguments, including the accumulator. The second argument is the current value. In this case, I'm going to leave it as letter, okay? I'm going to keep using letter. And we have right behind the callback here, the initial value, which is a string. So we're going to return a string, which means that we don't need to join, okay? The only question becomes, how do we get this data into the string? Well, we're already returning the letter. We just need to return the accumulator as well, okay? So we add the letter to the accumulator. It gets right there, kicks it out the door. And if we run this, we should get a passing test, which we do, okay? We can do it a slightly different way. Maybe you like regular expressions. Maybe you don't, right? But let's try it with a regular expression. So instead of all of this reduce stuff, okay, just right here, we're going to do replace, okay? And replace, you might have a string and you replace it with another string, right? Very, very common stuff. If you've been around for a while, you know that the first argument can be a regular expression. Inside of here, we might do those letters. So it is GCTA like this, okay? Because we want any of those, we put it inside of a range, right? So we have this, any of these letters is selectable. And we're only ever going to get one. So there's no plus in here or anything like that that might add on extra letters. We're only ever going to get one at a time, but we do want it to be across all of them. We want to find all of the things and do the changes. That's what the G is for. The G is for global, okay? From here, we normally have a string, but we can also do an argument, okay? A function, right? Inside of that function, we do get an argument. We're going to call that letter as well. And then we operate on this. And we've already seen that. That's going to be codes letter. So whichever letter it finds, it's going to change it to whatever it finds in codes. Okay, we get that callback. Everything else is just about the same. The problem here being that replace operates on the string, not an array. So we need to clean out some of this stuff for the array, just like this. Now we can run it and we get errors. Why? Because it looks like I have something going on. Let me double check that. 1, 2, 3. String replace, syntax, unexpected, something or other. I'm missing it, and it is right here. No, wait, let me check. Yes. For some reason, I have extra stuff in there. That's so weird, right? There it is. Sometimes they just creep in, right? Semicolons and extra brackets. Sometimes they just happen. This is something to do with CodePen. CodePen is breaking my heart again, okay? Failed to reload. It's doing the thing. We can get rid of that. I'm going to copy and paste all of this, hit refresh. Yes, I want to leave. And then I'm going to paste it all back in. just like this and run it. And I should get, I'm back to test number 3, but at least it's a little bit cleaner, okay? Because I don't want to be seeing those for all time through this video. But getting back to the code, we use that replace, we found the letters, and we replace the letters, okay? So we should be able to keep running that as many times as we want, and it will pass. It's very elegant. And at this point, the only question becomes, what about these letters, right? They're hard-coded. If I go in here and I add a new entry to my codes, I also have to update my regular expression, which is kind of a bummer, right? That's not where we want to be. So let's go and find a slightly better way on that, okay? Instead of this, what I'd like to do is add a regular expression here, and that's going to use new regexp with the P. Don't forget the P. I've done that. Trying to figure out why isn't it working? I forgot the P because I'm so used to just typing regex, right? But inside of here, we get some code, and that can be exactly the same. So we could go here and type GCTA just like this. And then we get the arguments separately, just like this, and replace everything inside of here with RE, okay? We hit it. We get a passing test, of course, but we are not done because I haven't actually updated this, okay? Instead, way up here, below my codes, I'm going to set const keys because that's what we want, GCTA. We want the keys. And I'm going to get object.keys codes, okay? That's going to return an array. So again, we need to introduce join. We smush them all together. And now we can use keys down in here. Because this is a string, we can manipulate it with variables, okay? And that's the key. Like with, as soon as you want to introduce variables into your regular expressions, you kind of need to pull it out to this new regex keyword, right? Or build system, okay? Because you cannot do that inside of the slashes inside of a regular expression. So you build the thing, and then you use this thing, and now if you run it, it should still work, which it does, okay? At this point, we have a really solid solution, right? We've done stuff. If this ever updates, if our codes ever update, we have a solution that does that all the time, okay? The key here and the thing that I want to switch to is how can we make this more universal, okay? So I'm going to switch gears for a bit, copy this, bring it down, paste it in, and we can start to change this a little bit. So maybe instead I have a new argument called to. And sorry, let's start with from. I want to start with from and go to, right? Now our tests are not expecting that, and I don't want to go and update all the tests. So instead what we do is we get some default values in here. And this can be GCTA, and over here, setting it to, what is it? It is CGAU, okay? And then we can use that. So right here we have from, and down here, instead of all of this codes, we get to, and we go from dot index of letter, okay? So a bit of a mouthful. Whatever letter it finds, it goes and finds the index within this string, translates it to the index over here, and uses it, okay? If I have this right, I should be able to delete all of this because we're no longer using that, and run it. Hopefully it works, right? And it absolutely does. At this point, I have a solution where maybe 2RNA is the wrong name because, hey, I can pass in any strings here. The only challenge is that these strings should be equal. As an example, if I type in X, right? And if X showed up in one of my strings here, but there's no similar letter on this side, right? On the to side, now it's going to throw like an out of range error, right? We're going to get weird errors in our console. So the only other thing that I would add here is maybe an if statement, okay? So if from dot length not equal 2 dot length like this, then throw new error. Again, probably should be better than oops, right? If this was production code, I would pick a better message, but for now that should work, okay? Now we can pass in anything in here. So long as they're equal, we're going to do the thing, okay? And again, we aren't actually doing anything special here, so of course it's going to pass. We should probably add in some new tests for that, okay? Check that path, okay? The final bit that I want to talk about is how to make this more universal, because right now we do have hard-coded DNA to RNA. We still have these two values. They're still kicking up a storm, right? And we can make this a little bit more flexible for everything, okay? So once more, okay, I'm going to create a function. And I'm going to call this translate factory. I'm not actually sure if this qualifies as factory, but because we're going to be able to generate a lot of different things, it feels like a factory to me, okay? We're going to get that 2, starting with from, going to 2. I don't know why I want to keep typing 2 first. It doesn't really matter, so long as we're always consistent, right? And then down here, again, a lot of this stuff, we are going to use it, okay? So I'm going to paste that in, but this part here, okay? I want this to be in its own function. In fact, I believe this one doesn't even have to be here. So that can go there. But right here, we are going to do some translating, okay? And the way that translating works, or sorry, we're not doing the translating here, but we are returning a function, okay? And inside of there is going to be this return statement. So that's where we're going to use that. Excellent, okay? We need to take care of this strand. I don't really want to use strand here because I'm making it more universal. Strand feels like DNA to me, okay? So maybe I just go with string and I translate this to, I change this to string. And then down in here, I can use that. So right here, I'm going to create a const. Maybe we call it translate RNA like this. We use that name that we had, copy it, paste it, and pass in our 2 arguments, right? This, we have our from, GCTA, spell it right, and our second one, which is CGAU as a string, okay? Getting rid of all of our arguments except for the strand, because right now, the last thing that we need to do is return, translate a RNA, and pass in strand. Hopefully this works. Let's go and take a look. I have made that mistake before. Yes, it absolutely does work, okay? So now we have a system where we just get it done. In fact, we can refine this more. Check this out. So instead of this, right here, I'm going to take translate factory, cut it away, and replace this entire function with translate factory. So now it's export const to RNA, translate factory. Translate factory returns a function, right? Which is what we had before. We had a function. And then when it gets used, it will pass in that string, because that's what we're expecting here, which will make the thing work. We can run it. Test 10. I'm not sure what actual test we were on because we refreshed, but it works and it's completely universal at this point, right? So if I wanted to, I could copy and paste this, change it to DNA, switch these around. So it's CGAU and this one is GCTA. I'm not sure if that's actually how that works, right? I'm not sure if they go back and forth, but for me, this works, right? Or maybe somewhere down here, right? I have, translate ROT13, right? A very simple Caesar cipher where each letter gets moved to its 13th position. So we might have A, B, C, D, E, right? And then here we would have NOPQR, I believe. Okay. So again, so long as they're accurate, this will still run. Everything still passes. Okay. Which means, what have we done? Okay. We're at the point where it's time to review everything that we've done. So scrolling way up to the top, we started with a very hard-coded switch statement. Okay. Which means that any changes require developer intervention. There's just no way to do it any other way. We'd have to go and add it in a line, do stuff, make it work. Okay. We pull those values out to its own object. The idea being that maybe this object comes from an API, right? So it can be updated in a different place, not in our code, but maybe in a CMS or somewhere else. So if they find new values for DNA, then they can figure that out. Okay. And our code will still just take those values and use them. Okay. Which is what we've done here. Now that's still used a map and a join. So we kind of clean that up using a reduce, one of my favorite tools, right? Reduce, which simplified things, got rid of the join. Down here, we switched to a replace with some hard-coded values. And then we kind of got rid of the hard-coded values and made a single source of truth. So again, if it was coming from an API and it updated, it would just work, which is excellent, right? At this point, we have a really solid solution. It is kind of specific. It's been named for DNA, RNA, stuff like that. So the last thing that we did was we tried to make it a little bit more universal, okay? That did require us to have a from and a to. We could probably change this a little bit depending on what we're doing, right? Or we could still use that single source of truth and pass it in. But this starts to work. And now the naming is a little bit weird, right? Because it's no longer to RNA. It's to any two equal strings, right? From this equal length string to this equal length string, add a little bit of error handling. And then we pulled all that out to a translate factory, to a factory, sorry. This factory returns another function. So it's a bit of a closure, right? Where we are taking in some of those values, doing the work, making it all happen. And we can use that for RNA, DNA, Caesar ciphers, and what have you. In fact, that's my question for today. What could you see yourself using this factory for, right? Is it just for Caesar ciphers? Is it for something more, right? Hit me up in the comments. Let me know. Thumbs up, thumbs down. Let me know that too. Okay. If you found this interesting or you didn't. And yeah, this is where I would leave it, right? It's very universal. I could use this anywhere. And I'm very curious in how you'd use it too. With that being said, I will see you in the next one.